Okay, I'm going to finish up this chapter. So we're on limiting reactants, and I'm going to turn we're just going to go straight into the definitions, okay? So let's go right here. When you have two different reactants and you've measured out each one of those reactants will limit how much product you can make typically. So the reactant that is totally consumed during a chemical reaction, that is called the limiting reactant. They will sometimes call it the limiting reagent, okay? Because it limits how much product I can make, okay? And then the other reactant, so the reactant that remains after the limiting reactant is completely consumed, is called the excess reactant or excess reagent. Okay, so let's turn to the practice problems. There are two sets of practice problems in this section. Okay, so the first practice set addresses how to identify a limiting reactant and determine how much is left over of the excess reactant when we're done. So again, there are a number of different variations of these problems that I could possibly do. So I'm going to try and pick one that goes over everything. Let's take a look at number 2 as an example, okay? For number 2, it says we've got an acid spill. We've got 12 grams of sulfuric acid. So that means you've got H2SO4. It's neutralized with 80 grams of sodium bicarbonate. And sodium bicarbonate is NaHCO3. Okay. And here, this is a double replacement reaction. You're going to form sodium sulfate and carbonic acid, which will decompose into water and carbon dioxide. So this needs a 2 here and 4 hydrogens. So a 2 here. We've got 6 oxygens, 10. So a 2 here be 4. Is that right? 4, 2. Yep, that's it. Okay, so 1, 2, 1, 2, 2 is our balanced equation. You've got 12 grams of sulfuric acid and then 80 grams of sodium bicarbonate. And they want to know what volume of water is formed. I'm going to assume they gave us the density of water has a unit of milliliters, so that means they really want milliliters. Okay. Notice we've got the quantities of 2 reactants. Anytime you have the quantities of 2 reactants, it's automatically a limiting reactant problem. They may not tell you it's a limiting reactant problem, but you are expected to identify that it is because you have the quantities of 2 reactants present, okay? From here, you have to do double the work. You'll convert grams to moles, moles to moles, and then you'll use the density of water, okay? So let me show you. I've got my 12 grams of H2SO4. I'm going to divide by the molar mass. Then I'm going to use the coefficients. And then I've got to convert to grams of water using the molar mass. And then I can use the density of water to get to milliliters, okay? I think sulfur is 32.07. Taking a guess at that. Yeah, it's 32.07 on your thing. Yeah, it is. Okay. So this is 4.41 grams, I'm sorry, not grams, milliliters of water, okay? I have to do all of this all over again with the other reactant. Okay. Once you get to here, the least amount of product that was produced is how much you should produce if you were to do this in the lab yourself. So you want to always identify the amount that you will actually produce by looking at the least one. So this one is the least amount of product. Therefore, this is how much you should make. We have a word that we call that. That is the theoretical yield. It's how much I should make if I were to do the experiment myself. Okay, and it's a good idea to identify it. Okay. From there, you would want to identify which reactant produced it, or which reactant is the limiting reactant. So whatever reactant produces the least amount of product, that is your limiting reactant. So H2SO4 is the limiting reactant. A lot of students forget to identify the limiting reactant. They simply put a box around the theoretical yield and call it a day, and assume that you know that the one that produced it, that's my limiting reactant. You're totally cool with abbreviating limiting reactant as LR. That's totally acceptable, okay? Now, the other question that you might get is, how much of the excess reactant would be left over? Okay. In order to figure this out, you have to do something similar to what I just did. The only difference is you're going to start with the limiting reactant and you're going to go over to the excess reactant. So what I mean by that is, let me do this in a different color. You're going to take, let's do this work down here, okay? So you're going to take your 12 grams of H2SO4, and we're going to convert that over to a mole by dividing by the molar mass. And then you're going to compare it from H2SO4 to NaHCO3. So we've got 1 mole of H2SO4 for every 2 moles of NaHCO3. I need to go to grams of NaHCO3 because that was the unit that I started with. Okay, so I'm going to convert over to grams. So this is how many grams I will use in the experiment, okay? So we're going to get 20.6 grams of NaHCO3, okay? So this is how much we'll use. So that means I need to figure out how much is left over. Well, how do I do that? I just subtract. I take the amount I was given and I subtract the amount that I'm using, and that will tell me how much is left over. So this is going to be 80 minus 20.6. And you're going to get 59.4 grams of NaHCO3 left over or remains. Okay. All right, so that's half of this section. Any questions on that? Okay. The last half of this section has to do with percent yield. Okay. So the percent yield equation is given on the next page, and I'll wait a second.